All right, today we're doing chapter 4. I have not gone through and checked for rounding errors and stuff like that. I am hosting a boot camp for Python coding this weekend. And so I got a bunch of work I gotta get done for that and other things. It's for the computer science students. And so I didn't get to grading. I'll be working on it this week. I hope I have everything in by Wednesday, so you guys will have a better idea before the drop date where you're at. But generally, even with rounding errors, very rarely does someone get an extra 10 points. Keep in mind that the final, the midterm's only 20, what is it? What percent of your grade is it? Let's find out. I think it's 25, but I want to make sure. It's either 20 or 25. One way to find out. $25. Okay, so even if you got like a 50% on the midterm, you can still pull out a B+, a strong B+. Might even get you close enough that I'll round up to an A. That's if you only got a 50% on the midterm. So it's not the end of the world if you bomb the midterm. Homework and quiz, we're going to be doing a project in a couple of weeks. We'll start a project in, I don't know, 2 or 3 weeks. That you'll do as a group. There's plenty of ways to still pass this course. Of course, homework's 20%. If you're not doing your homework, everything gets harder from here. The final is easier than the midterm. It's in class, it's on paper. I will do all the math for you. I'll spit out the results from StatCrunch. And your job is just to interpret the results from StatCrunch and say what it means. And you'll see as we're doing the next few chapters, it'll make much more sense. It's definitely easier. But haven't graded it yet, we're getting there. Today we're doing chapter 4. This is on linear regression. And just a little quick blurb for you. This chapter is not going to be on your final at all. But as you're going through doing the homework, they will every once in a while reference check to see if it's normal and stuff like that. And what we're doing today, 4.1 and 4.2, and what we're going to do next Tuesday, 7.3, will give you some more answers for the homework later on. But this part is not on the final exam. This is a lot of stuff with graphing in 2D. Now, if you've been attending the 321, the support class, or watch the videos, we've done a lot of this stuff. The idea is that we will get lines in the shape of y equals mx plus b, where m is the slope. And a lot of people know it as rise over run. It's how much the line goes, it's a fraction, how much the line goes up over how much the line goes to the right as you go from left to right. I'll show you a couple examples in a second. B is the y-intercept. And it means there is a coordinate 0, b on the graph. I'm not delving into it too much because, again, there's hours, I think we've done 3 or 4 hours worth of support course material on this. If you're curious and want to know more, you can watch those videos. The horizontal line is called the x-axis. The vertical line is called the y-axis. And we might have 2 points and they'll have a line going through it like that. Or we could do a line going down like this. I wish I'd picked different points, but oh well, that ship sailed. I picked different points this morning and it was easier then. All right, so the rise and the run, let's just take a look at it. It's as we go up and how much we go right. So I'm going up 1, 2, 3, 4 units up. And 1 unit, 2 units, 3 units right. M here equals 4/3. And unfortunately, it's hard to tell, but this crosses this line right here at 5/3. The previous class, I picked points on that line to make this easier. So we could see lines like this. The computer will not give it to you like this. They will always be in decimal form. So the computer work will always be in decimal form. If I check it on this one over here, I'll see how far. Here I'm going down as I go to the right. 1, 2, 3. Down is considered negative. I'm going right 1, 2, 3, 4. So here m equals -3/4. And that means I'm crossing this point at -5/4. So y equals -3/4x minus 5/4, because b is negative here. That point is called, these 2 points where I did the 5/3 and the -5/4, those are the y-intercept. Now, something the homework is going to focus on a lot. It'll not a lot. It'll mention several times, not a few times at least. One way, a useful way of reading the slope every time x increases by 1. Y increases by m. So if I look here, M here was the 4/3. When I went right 1, I went up. 4/3 is the same as 1 1/3. I went right 1, I went up 1 1/3. If I look over here, that's about 1/3 of the way up between where they meet and the first hashtag. The center here is 0, 0. Oh, that's not the point. I want it in red. At this point, x equals 0 and y equals 0. Ready for more? I see a couple people writing. Slow your roll, Jones. It's not a race. Okay. All right. We'll take a look at something called scatter plots today. Sometimes they're helpful, sometimes they're not. It shows the relationship. Scatter plots show the relationship between two quantitative variables. We plot the points on an XY graph. And look at the trend as it goes from left to right. I'm going to bring this picture back up for a second. So if we look at the graph on the left up above, on previous page, as we go from left to right, the graph goes up. This is true for all slopes M that are greater than 0 or positive slopes. the line will look something like that. It'll go up as you go to the right. And if you look at the other one, graphs that go down have a negative slope. M is less than 0. They will point downward. On scatter plots, we can do a line of best fit. And I'll describe mathematically what that means near the end of this lecture. So we can actually take a look at it a little bit better on scatter plots. And then for scatter plots, the x variable is the explanatory variable. Oh shit, that's all the way back to chapter 1. Look at Jones bringing up the old shit. And the y value is the response variable. Something you're going to find useful is on Canvas, and I'll show it to you. And I'm going to use it myself today. If you go to Files, Useful Handouts, I'll show it to you in a second, just writing it down so it's in your notes. And then Stats, there's a document that's called Stats, Formulas, and Tables, I think. We're going to use that on page 5. Table 2 is critical values. Okay. Let's go take a look at it. We're here, if you click on files on the left. I don't know where it is on the phone. I think the drop down menu is in the upper right on the phone. Canvas is not phone friendly, despite what they say. It will say useful handouts and stats. Stats, formulas, and tables. Now, before I scroll down to the table, I want to show you what's in chapter 4. Look at this bad boy right here. Look at that equation. We are working with the correlation coefficient today. Be thankful StatCrunch exists. It's going to do all this for us. Doesn't that look like an MFer right there? Even if you don't cuss, you'd be like, MF. Fuck Jones and his fucking shit. We will do residuals. We're going to do this by hand. We'll work at residuals by hand because it's not too bad. What I brought you here for was tables. It's way down here. I might have got, nope, not far enough. Table 2 has critical values for correlation coefficient. This will be chapter 4. And I believe table 6 is what they use for 7.3, which we're doing normal probability plots there. We're gonna do that on Tuesday. I originally scheduled it to try to get it in today, but I think I'm forcing the lecture too fast if I try to do that. We'll be fine though. I'll leave that here. We're gonna use it later today. Be appreciative of StatCrunch. It's blessed. Does anyone need this part of it longer? Okay. So we've got this correlation coefficient. It's called R. R, and I think sometimes you'll see big R. Big R, capital R. What we use it for is we use it to test for linear correlation. Between our explanatory variable X and response variable Y. We've used the word correlation before. We've talked about it before. It's when things either go up together, like when one value goes up, the other value goes up, or they have a upside down relationship. One value goes up, the other value goes down. We talked about this several weeks ago with ice cream and crime in July. You guys remember that? They both go up together. The ice cream sales and crime are both high in July, but neither one causes the other. There's a correlation because they go up together. So it's important to know that even if we show correlation, correlation does not mean causation. Don't think that it does. One does not show the cause of the other, even though we're going to show a connection between the two. We'll do that on our example today. Okay, so types of correlation. Where is my black pen? I said we're looking for linear correlation, so let's look at the two examples of that. First. Yeah,
Some assholes talking crap.
I don't know what I have for, it's making me so aromatic. So scatter plots have points for the data. And I'm just showing ones where they have an uphill trend and a downhill trend. There's no rhyme or reason to my pattern, my dots. We could have ones that are way outside of it. But for the most, they follow along. Linear talks about lines, so if we do the line of best fit, these might be the lines of best fit. This one goes uphill, so the slope is positive. We call this positive linear correlation. And this one, the slope is less than zero, goes downward as we go from left to right. This is negative linear correlation.
That kind of in relation to like maybe when the stock market's on a rise or it crashes or any of that, like when the Dow is up and the Dow is.
Sometimes they tie it to things.
Okay,
Oftentimes there's a tie to things. Like if there's a major drought or something, crops don't produce. An entire food sector drops in the stock market. So there's a correlation between the drought or, the day's rain and the stock market, even though, and that's probably a causation for part of it. But in terms of what like a stockbroker does, I don't fucking know.
yeah,
If I did, I'd be a stockbroker because I think they make even more money than I do. I'm pretty happy with my income. I live a simple life, house, family, no kids. I have a lot of expenses. Just good food, as you can tell. I like to eat. All right. Did anyone need that longer? Okay, so there's other types of correlation. There's nonlinear correlation. And then there's no correlation. My dots could be going up, but then they decide to turn and they come back down. Or they could start high and they could go low and turn around, come back up, and then come back down again, make something like a wave. But there's a way I can draw a line that kind of follows the data. There is a correlation, but it is not linear. It's not a line. In mathematics and statistics, lines are straight. These things are called curves. Then there's no correlation. The dots are just fucking all over the place. You ain't making a line. In this class, we are going to focus on linear correlation. Right? So let's look at that correlation coefficient R. And properties of it. So the first real big important thing to note is R is always between -1 and 1. The closer R is to -1, the stronger the evidence of negative linear correlation. And if R equals -1, it's called perfect negative correlation. Linear correlation. I don't want to write it all out. All we did is add the word perfect in front of it. Yeah,
What is the word thing? Where it says the color R, I'm sorry, the closer R is to -1, the what?
the stronger the evidence. Uh-huh. And let's change color to make it so it doesn't blend. The closer to positive one, the stronger the evidence for positive correlation. With R equaling 1 being perfect positive correlation. If R is close to 0, close to or approximately 0, there is little to no evidence of correlation, of linear correlation. Other forms of correlation might apply though. Toot, toot, toot goes the David. Scream, scream, scream goes the class. All right, you guys ready?
I'm on the part evidence
Okay.
here at the bottom.
I didn't even look around. I just asked. Could have looked around and seen pins moving. That was just being lazy. Like really lazy. All I had to do is turn my head. That's next level lazy. I just wasn't thinking. I gotta go home and fucking make lecture video or lecture notes for tomorrow's class for computer science. Which means I'm gonna be up till 10 or 11. It's been a long day. Class started at 8 a.m. for me and then all go no quit except for an hour nap in the middle. And lunch. And lunch.
Is that a salary kind of thing, or you just go all the way through? 'Cause
It's salary for the first 15 units. Anything over 15 units is extra pay.
oh, wow, okay,
Anything over 40 students per classroom is extra pay.
wow.
Haven't had that since the pandemic. Before the pandemic, I often get 45, 50 students in a class enrolled. But since then, no.
Yeah.
All right, we got a couple more rules that apply here. Looks like you've done writing that shit down.
Okay.
Number 2 is R is unitless. It's just a number. Like when we talk about time like 5 minutes, minutes are a unit. It's not just 5. R is just a number. There's no units that go with it. And R is not resistant to outliers. There's 2 ways to get the correlation coefficient. We can do stats, summary stats, correlation. And from there, pick the 2 columns. Pick 2 columns of data that we're checking. The other way I think is more useful because it yields more information. Correlation just yields that. We can also do stats, simple linear. Oh, nope, fucked it up. Stats, regression. Then simple linear. Got to do them in the right order or you ain't gonna find it. Again, you have to pick the 2 columns, but this gives more data. This gives R and the equation and line on a graph for line of best fit. Okay, so what do we do with it? With R, we compare it to the critical value from the table. And that value depends on N. Sample size. So once we find R, calculate, or I guess calculate's a heavy word for saying do the absolute value of R, which is really just look at the positive version of R. Absolute value means a lot more than that, but in terms of this, what you need to know here, it's a lot more of a lecture rather than just saying make it positive. If the absolute value of R is greater than the critical value, there exists a linear correlation. And then you have two categories. If R is greater than 0, it's positive linear. And if R is less than 0, it's negative linear. The other option is if absolute value of R is less than CV, there is no linear correlation. And after you get that in, let's take a 5-minute break. We're at a nice little pause point here. So for the next part here, we're gonna do an example. If you're using the computer and you want to follow along, in my math lab, click on StatCrunch tab. And you'll see the option data sets from your textbook. We're going to look at 4.2. I think this is how they have it written. The question they're doing here is there a correlation between the length of a bear and its weight? And I'll pull up the table in a second. I'll show you how to get there, but I already got the numbers written down. So I'll start writing them here so that you have them for your notes. The length is in centimeter, the weight is in kilograms. So clearly this was not an American. And I think every two, I'll make a little line. That way it's a little easy to see what goes with what. Those are the lengths. And I'm pretty sure these lazy fuckers rounded to the nearest 5 on the weights, because there's absolutely no way these bears all had weights that end in 0 or 5. 95, wait, hold on, 85, 100, 95, 85, 155, 140, 105, and 110. See what I mean? There's no way. There's no way in hell. I'm gonna start off and show you the graph with the scatter plot. So to get to it, it's graph. Scatter plot. And then you pick X, pick X, pick Y. And we're seeing if there's a correlation between length and weight. We're going to use X for the length and Y for the weights. Then we'll do the stats, summary stats, correlation. And on this next page, I'll do the other one. That's the other one is the good one, I think. The regression one. Oh. At least one person's still writing it, it's certainly not. Fuck. I still got a lot too many lecture notes to do today. That's the problem with teaching a new course. The first time you teach it, you gotta write a lot of lecture notes. After they're written, I can just keep reusing them. The topics don't really change. But an entire semester worth of lecture notes, you see how some of your notebooks get. I gotta write just as much. All right. So I'm gonna come over here. I'm probably gonna have to log in again. I did not have to log in again. Excellent. So we're gonna go to click on StackCrunch. Click on view the data sets from your table or textbook. You MFer. Now you're gonna kick me out. Am I not enrolled? Let's try this again. Let me sign out real quick. So we want chapter 4, and I'm doing 4.2, number 7. So this has got the total lengths and weights of my bears. The bears. We're gonna do a graph and a scatter plot. We'll do the length in X and the Y variable for weight. I recommend leaving it as points. I'll show you what lines look like in a second. There's a couple ways to display it. That's the points, and it kind of looks a little bit all over the place. If you try to do lines, this looks shitty as hell. It's playing connect the dots in the order that they're on the list. So don't do that. Don't do lines, do points. Now, not that helpful, but we'll see it again. Sometimes it's like really clear. All the dots make a line. You're like, nope, I know that's good. I don't need to check anymore. Then we can do stats, summary stats, correlation. And when I do stats, summary stats, correlation, I will pick both columns, just highlight them together. And just click compute. And it says the correlation between total length, cm, and weight, kilograms, is 0.7039. That's my R. That's the R we want. We also need the critical value. If you've got the data in StatCrunch, you just look at how many rows there are. That's your N. N is the number of entries, number of bears. There were 12 bears here. So N is 12. That's what I'm going to use on this table over here. So I still have it up. N is 12 is right here in the middle. And it says 0.576. So I'm going to come back over here and we're going to say, we compare the absolute value of R, which is still the same thing. I'll use 3 decimal places like the critical value, just because I'm tired of writing it all. And we want to compare that to the 0.576, which is my critical value. The absolute value of R is greater than the critical value, which means there is a linear correlation. Exists. And since R was positive, that means it's a positive linear correlation. Okay, so let's go look at the other option we had. Stats, regression, simple linear. All right, when we click on it, we still got to tell it where the X value is and where the Y value is. And don't worry about the rest of the stuff for now, just click compute. It's got the fitted line plot already selected. So there's a couple things to notice. It's got my R. It even flat out says correlation coefficient. That's what we had from the other screen. We can see it right there. It's got a graph here with a line on it. That's our line of best fit, which we're going to talk about right now. And they give us the equation for the line right here. I'm going to write this. It's a little hard to read the way it is. I'm going to write it down on the document. And while I'm here, I'm also going to point out, I'm going to talk about what this thing is right here. It's the SS error. I'll talk about that in a second too. So when I do stats, regression, simple linear, it gives me R. And it also tells me weight kilograms equals, and I'm going to round to 2 decimal places here because there's a lot of writing, plus 1.69 total length centimeters. Now, when I was picking columns, I said this was the Y column. And total length centimeters was the X column. So what this is really giving us is Y equals negative 142.47 plus 1.69X. Which is I'm going to slap the shit out of the StatCrunch people for fucking it up way of writing Y equals 1.69X minus 142.47. This looks like Y equals MX plus B. We have it in this format. You put it in the right order, it's useful. The order they give you, it's not all that useful. So my M here is 1.69. And my B here is negative 142.47. This line right here is the average length of bears. And I'm sorry, average weight of bears. Let me just try rewriting it so it doesn't look sloppy. Based on length. The homework is gonna, if you look at the help me solve this and shit like that, at some point it's gonna show you something that looks like this. It'll say this. This is our M and this is our Y intercept. And the way they calculate it, they do this for us. B1 equals that R, that correlation coefficient we had. And they multiply it by this standard deviation of Y over the standard deviation of X. So this is like Y hat here. This is Y hat. It's the same thing. This equation for the average weight of bears can be used. We can use this to predict the weight of a bear. If we know its length. Because let's face it, how easy is it to find the weight of a bear? Come, Mr. Bear, please stand on this scale. No, they had to fucking tranquilize these bears. Put them on a scale. Weigh them to get it. Length is easy to get. You can take a picture of them when they're near something, and if you know the length of the other thing, they do this in profiling all the time. When they're like identifying a suspect, compare to the person next to the door frame and go, that motherfucker is 6'3.5". Because they know how tall the door frame is, and they know how big he is compared to the door frame. They can do the same thing with the bear. They can get the length of the bear just from a photograph. Getting the weight of the bear, that's another story. Drugging that motherfucker and dragging a heavy ass bear, putting it on a scale, and I'm pretty sure these numbers are fucking made up or rounded a lot. Because you don't get things that end in 0 and 5 for every single data entry. It's just not feasible. But this was for 12 bears they weighed, presumably. We could have a 13th bear, and without weighing it, we can use this line to estimate about how much it weighs. So Y hat is called the predicted value. It's also called the predicted value. And it's for a given X. In this case, length. Everyone ready for some more? Okay. So let's predict it. I'm gonna rewrite that Y down on this page. And before I do, I want to show you something. Go back to the picture, the graph. So, like, these are the actual bears. The bear, where the bear showed up. And it gives their length and their weight when I look at it. None of them are on the line. That's normal. Every once in a while, you might get 1 or 2 on the line. If it's all like a perfect match where you get R equals 1, they're all on the line. But what we're about to measure is the distance vertically from our dot to here. So what we're going to do, we're going to calculate what that weight is for a couple bears. Let's pick this bear. This bear is really close. This bear's got a weight of what? God damn it. There we go. I'm going to do 2 bears. We'll do the one that's got a length of 150 and a weight of 110. And this one looks really far off. Let's do this one. That one has a length of 138. No, let's do one that's above it. Let's do that one. Length of 129.5 centimeters. And we'll have the weight is 105 kilograms. So that's the actual weight of the bear. If we use the formula, let's see what the predicted weight would be for those bears. So I wrote the information down here. What we're doing, remember, X was length and Y was weight. So we're going to plug in the length. And find out what the predicted weight is. So the predicted weight, when we do these calculations, I'm getting 111.03. So 111.0 kilograms. We'll do 1 decimal. We'll do the same thing here. Feel that's really low. I feel like I fucked that up. No, I didn't. So predicted weight. $76.4 kilograms. So neither of these are on, right? The top one's really close. The prediction is really close to the actual bear. And the dog was really close to the line. Here, the prediction's really far from the weight of the bear. And this one was way above the line. So there's some error here. Error between the two values. Error generated by using the line. This error is called the residual. And the way they calculate the residual is y minus y hat. Where y is the actual observed value of the bear minus the predicted value. For bear number 1 up there, observed was 110. Minus 111.3, I get a negative 1.3. Bear number 2. Observed was 105 minus 76 28.4. $28.6. I'm doing that in my head. I'm not confident in it. $28.6. So Bear One's weight. His, I don't know if it's a his or a her, but I'm gonna say his. His weight is less than expected. And bear number 2 is heavier than expected. Okay, so what else can we do with this? So this residual here, this y minus y hat. It's the error from using the line. To estimate. And each one's different. And the way it's doing it, like visually on the graph, like say there's our line. One of our points was really close and one of them was really far away. It's measuring the vertical distance here. So this was our 28.6. And this was our negative 1.3. It's measuring the vertical distance here. So the way they find the line is they do this. They do a shit ton of calculations. Well, no, they don't. That we already said it's R times SY over SX. They already showed where they find that. What this line does, what the average line does, is minimizes the sum of the squared errors. Sometimes called sum of squared residuals. They go through and they do this y minus y hat. They square each one and they add it up. And the line that has the lowest value when you do that is called the line of best fit. This produces the line of best fit. And this process is called least squares regression. This whole sum of squared errors thing right here in StatCrunch on that simple linear regression thing. At the bottom, it had SS and it had error. There's a table. And the entry for this one, I'll show it to you in a second. This was 4,350.4367. I'll just do the 1 decimal place because I didn't give myself a lot of room. SS stands for sum of squares. So this is that sum. What I did with the bear that's below weight and the bear that's above weight, they're gonna give you a problem in the homework that does that. They're gonna be like, what about this bear? This bear has a length of so-and-so and a weight of so-and-so. Is the bear heavier or lighter than expected, the average bear? You're gonna do the same thing we did here. You'll have a problem like this. So I did a couple examples. Remember to check out your notes. When you're looking at it, you're like, what the fuck is this? We did a couple examples in class. We're almost done. A little bit more information to go over with you. Good, Angel? Just wanted to show it to you real quick. SS is sum of squares. And he gives us that. This stuff is for hypothesis testing. There's a bunch of shit here. This is an introduction to stats class. If you want to learn what all that shit is, become a stats major and suffer. All right, so what's going on with this thing? The longest or the shortest bear, our bears ranged in length from 120.5 centimeters up to 166 centimeters. That equation is only good for bears near that length. For example, like picture a bear cub. Now, I don't know how long a bear cub is. But like a meter is like close to 3 feet. And so I'm thinking like even a newborn bear is at least half a meter. Like just coming out, probably bigger than a half a meter, but let's go with half a meter or 50 centimeters. Our equation says 1.69 times 50 minus 142.47. Equals negative 57.97 kilograms. You're gonna remind this is a weight. What's wrong with that statement?
Something negatively.
Can't weigh net less than 0. That didn't make any sense. Okay, so it's not good outside you can go a little bit outside of it. We might be able to, you might be able to go maybe like, I don't know, 110 and maybe up to 180, but too far outside the range, the equation stops working. Okay. Mark Twain actually noticed this with the Mississippi River. I don't know why he was looking up Mississippi River lengths over like on the table, like they recorded it every 10 years or 20 years or some shit like that. And every once in a while, like the river finds a new path going from the north of the US down to the Gulf of Mexico. It finds a shorter path. And so it carves a new way. So the river got shorter over time. And he noticed that if you took that data set, just like we have this data set of bears, if you extrapolate it out over the next 200 years, he actually had by a year so, he said the river was going to be like 30 miles long or some shit like that. And it's literally going from, I don't know, Montana or where, I don't know where the fuck Mississippi River starts. I'm not a geography major. It starts in northern US. It goes the full length of it, it's at least 1,500 miles. It doesn't get, you can't get much shorter than that. A straight line is the shortest. But like if you use that, like made an equation with the data, it would show the Mississippi River should shrink down to impossible. So it's only good up to a certain length. The M is pretty good though. This M is useful. What this is telling me, if the bear gets 1 centimeter longer, the average bear gains 1.69 kilograms. Remember, this is the reading the slope. If X increases by 1, Y increases by M. Almost there. Hang in there, stay on target. I'm gonna come back over to the graph real quick. Just illustrate something. Notice that the lowest X gets is 120 and the lowest Y gets is 60. Okay. If we were to draw the graph with the information we have though, this tells us the y-intercept. Which means the real graph. Like. It had, 50, 100, 150. If I went the other way, negative 150. Like, if the line kept going, it would have intersected down here. And was doing some stuff like that. They only showed us this region. That's what they showed us. So. When we have the y hat equals b1 x plus b0. I don't want to call it the y, and it is the y-intercept. But like, do we interpret that y-intercept? So there's two reasons or two things you should look for. One, are there any x values close to 0? And then if so, does x equals 0 make sense? Reasonable sense. If either one of these doesn't apply. Don't try to interpret that B0. It has no applicable meaning. That's a dead pin. All right, so for us, there were no values close to x equals 0. 120 was the smallest value. That's not anywhere near 0, right? And the other thing to look at, just think about, does x equal 0 make sense? When we're talking about the length of a bear, does it make sense to have a bear that's 0 centimeters long? No. It's got no like realistic meaning. So don't regard that. The slope is always useful. But that y-intercept isn't always useful. And that will be it for chapter 4. I